Hello geometers, and welcome to the video on finding area of rhombuses depending on what type of information that you are given. This picture here is kind of hard to see, but this line segment here is 5.53 and this one down here is 8.33. And what we're looking for here is the area of the entire thing. Now there are definitely formulas for finding areas of rhombuses, and you can certainly look them up and try to memorize them, but none of that is as effective, powerful, and long-lasting as discovering and solving these problems for yourself. So to start, we should recall and review some properties of a rhombus. So a rhombus is a parallelogram. So those two lines up there and these two over here are parallel to each other. And it has four congruent sides. Okay, so all four of these sides here are congruent. And it has diagonals that are perpendicular to each other. Okay, and this is really key. This fact right here is kind of a big deal. And it's going to guide our problem solving for all of these other problems. So the diagonals are perpendicular to each other. So that means this angle right here, and all of these angles in fact are 90-degree angles. Okay, and not only that, the diagonals bisect each other. So this length, these two lengths here are congruent, and then these two lengths here are also congruent. So what you really have here is four congruent triangles. So if you want to find the area of the rhombus, find the area of one triangle. So the idea here is find the area of one triangle. Okay. Then multiply by 4. Okay. And this is really the main idea, and it makes it very simple for a rhombus because you have four right triangles. So the base is one of the legs, the height is one of the legs. Okay? So for this problem, you don't have to do much with finding these side lengths. It's much easier just to find the area of one triangle. So the area of one triangle here is, and I'll just specify here, this is the area of triangle BEC, is equal to 1/2 the base, which is 8.33, times the height, which is 5.53. Okay. And then whatever that is, I am going to take it and multiply it by 4 to get the area of the rhombus. So the area of the rhombus ABCD is equal to simply 4 times all of this. And I'm purposely not multiplying them out yet. I'm just going to write this long expression. I'm going to do some simplifying here. 4 times 1/2 is just 2. 8.33 times 5.53. Okay? And this will give us the area of the rhombus. Okay, so we multiply all that out and we get 92.1298 unit squared. And this is an exact answer. Depending on what your teacher tells you to round to, you should round to that. But this is the exact answer. There's no decimal approximations here. Those are all exact values. Okay? So let's keep this idea in mind here, finding the area of one triangle, then multiplying by 4 as we work our way through all the rest of these other problems. So let's look at our second problem. You have a rhombus where AC is equal to 12, so this whole length here is equal to 12. But remember that the diagonals of a rhombus bisect each other. So if AC here is equal to 12, then this length here is equal to 12 divided by 2, or 6. And BD, this length right here, is 20. So that means half of that length must be precisely 10. Okay? And the angles in the middle here are all 90-degree angles. So that makes this problem really simple to solve. The area of one triangle, BEC, is equal to 1/2 the base, which is 6, times the height, which is 10, and this gives us 30. Okay, but the area of the rhombus, the area of A, B, C, D, is 4 times that, so 120. This is units squared. Okay. So I'll end this video here, and we'll start another one that discusses some of the other problems. Thank you for watching. Have a wonderful day.